All right, guys, I'm here for a couple more examples of the harder problems. I'm reading number 3 next. Number 3, we're trying to factor 3n squared minus 8n plus 4. Same idea as before, guys. We want to find numbers that multiply to AC and that sum to B. Okay, so 3 times 4, A and C. 3 times 4 is 12. So we want numbers that multiply to 12 and they add to negative 8. Okay, because negative 8 is the B term, is the term in front of the singular variable. So numbers that multiply to 12 that add to 8. To negative 8. Keep saying the wrong things. Pretty clearly here, guys, because they're going to add to a negative and they're going to multiply to a positive, they're going to have to both be negative. So what are some numbers that multiply to 12? Well, negative 1 and negative 12 do, but they don't combine to 8. Negative 2 and negative 6 do, and they actually do combine to negative 8. Negative 2 times negative 6 is 12. Negative 2 plus negative 6 is negative 8. So again, kind of like before, we're going to split up this negative 8 term as those two smaller terms. Over on the side is what I was talking about. Negative 6 times negative 2 is 12. Negative 6 plus negative 2 is negative 8. These kind of always factor, guys. In theory, there are problems that don't factor. I don't think they're on the worksheet, where you'd have to use the quadratic formula to beat those problems, which takes a little bit more time. But in this worksheet, guys, if you're having a hard time coming up with numbers, just pull your calculator, guess and check a bunch of times. You can figure it out. So anyways, we're going to use negative 6 and negative 2. I don't know why that made such a large noise. So we got 3n squared. I'm going to put the negative 6 first. It really doesn't matter what I put first here. Over here. So step 1. We split up our 3 terms into 4 terms. I understand it's getting more difficult. However, it's going to come together really nicely. We find now the GCF. There should be an N. I don't know why I wrote N there. No, it's just a bolded N. We're trying to find the GCF of the first 2 terms. The biggest number that can go into both 3 and 6 would be 3. The largest variable that can go into n squared and n would just be n. So 3n is our GCF. All right, pause here. I look at the coefficients. I see 3, I see negative 6. 3 is the biggest number that can go into both of those. So I pull out a 3. N squared, this has 2 n's, this has 1 n. The most amount of n I can pull out of both of them is just 1 n. And now I ask myself, 3n times what gets me 3n squared? Well, 3n times n gets me 3n squared. 3n times what gets me negative 6n? 3n times negative 2 gets me this. And you might say, man, there's a lot of steps here, but look how much practice we're getting. We're getting practice with our integer multiplication. We're getting practice with our GCFs. There's a ton of meat on the bone here. So anyways, that's our GCF here. Remember in the last video, guys, whatever you wrote in parentheses right here, rewrite in parentheses right there as well. And then same idea as before. What times n gets me negative 2n? Negative 2. Notice here, guys, how kind of the form of our little strategy works nicely. Negative 2 times negative 2 is 4. And now these are just going to combine to our unfactored form. What you take the two GCFs, 3n and negative 2, those are going to combine. And then whatever kind of common term you wrote in parentheses, that's going to be your other term of your factored form. And we're done. If you wanted to FOIL this, you could and verify that these are the same things, but it's just a little bit more kind of palpable to use this in a lot of situations versus this initial form. So we're done. Your problem should look like this, guys. I haven't had too much of an issue with kids not showing work, but most you should show some amount of work here. You may don't have to write on all this stuff over here, but you certainly should show at least a couple lines of work. All right, let's do another example. And I'm going to skip a couple because this next couple didn't seem that bad. I'm going to do number 9. Number 9 is this. We have to use a skill we learned in the last section. So please pause the video here, write this down. It is 15n squared. 15n squared minus, you can read. That says 27, that says 6. Okay, so first things first here. If you ever notice that every single, term can be divided by the same term, there's a GCF initially, essentially, pull that out. I notice here, just kind of eyeballing this, that everything here can be divided by 3. If, let's say I didn't notice that, I could still do the problem using the way we did before, but it's a little bit easier. I make this thing a little bit smaller. It's gonna make the multiplication a little bit easier. So anyways, I can pull out a 3 from all these terms. I'm gonna go ahead and do that. So 3 pull out of 15, it would be 5 is left. Negative 27 divided by 3 is negative 9. Negative 6 divided by 3 is negative 2. And now basically, guys, I'm doing the exact same thing we did before, but I'm gonna just have this kind of 3 in front. He's just gonna come along for the ride. I'm gonna do this. It's just gonna be tagging along the entire steps of the way. And then that's just kind of it. So same idea as before, guys. We're doing AC method. So A is 5, C is negative 5. We need numbers that multiply to negative 5 that add to negative 9. I'm sorry, 5 times negative 5 is negative 25. We need, that's a 2. It's really hard to read from behind. Okay, let's retry that. We have 5 and negative 2. We need numbers that multiply to negative 10 that add to negative 9. So again, you do AC, 5 times negative 2. This is equal to negative 10. I cannot read behind the paper. We're looking for two numbers that multiply to negative 10 that add to negative 9. Again, if you're good doing this in your head, more power to you. If you're not great at this, use a calculator. Hopefully you recognize that it's going to be a negative and a positive. Whenever they multiply to a negative 10, we know one's going to be positive, one's going to be negative. This is going to be negative 10 and 1. Again, you could have tried 2 and 5, negative 2 and 5, but those wouldn't really add to 9. So negative 10 times 1 is negative 10. Negative 10 plus 1 is negative 9. We're going to split up this into that. And the 3 is just going to come along for the ride. I'm going to put the negative 10 first. It doesn't matter which one I put first. Same idea as before, guys. So I have this. I now have these two kind of pairs. I'm going to find the GCF of the first pair. I'm going to find the GCF of that pair. Okay, so we ask ourselves, what's the biggest number I can pull out of 5 and 10? The biggest number I can pull out of 5 and 10 would be 5. So this is going to get a little weird. That 3 is still out on the outside. I'm going to switch to brackets. He's just coming along for the ride, literally. So 5 is the greatest number I can pull out of both of those. And the greatest variable I can pull out would just be a single n. Because this has 2 n's, this is 1 n. I can't pull out 2 n's when there's only 1 n there. So I'm going to pull out 5n. That should be 5n. Okay? So now we ask ourselves, 5n times what gets me 5n squared? Well, 5n times n gets me 5n squared. 5n times what gets me negative 10n? 5n times negative 2 gets me negative 10. So that's why I wrote down n minus 2 here. Whatever you wrote in this parentheses, I like you to also write in that parentheses. And then we just ask ourselves, what times n gets me 1n? Well, positive 1. And notice here, positive 1 times negative 2 is negative 2. So it kind of works for both. And then everything comes together. The 3 is still in front. The 5n and the 1 come together, so 5n plus 1, and the n minus 2's come together. Okay, so that's that, guys. I'm running out of time on this video. I'm going to post a couple more examples of just kind of the work for a couple. I'm going to post another video as well of someone else doing this. I don't love the way I'm explaining it, but it works enough. Again, I understand there's a lot of moving parts, but the goal, again, is not just get the right answer. It's if you can do all these steps, you'll have to learn so much other things as well. It's going to make you a better mathematician. With that, I bid you guys adieu. Hope you guys are okay. Again, those of you missing work, I'll take it really late. I'm giving pretty much full credit for all late work. Hope you guys are okay. I'll see you next year if you're back at Tech.